remove all this. It's this is last X baseline. What does it mean by last? Let's see. It's so this is a text, right? Hello developer, and then that. So each text is a different box. The first text baseline means first text asset or first word in the text. Is it like that? Is that a line not specifically to security things and type of the system handle text? So first word versus the top first, there's nothing to the first node, it aligns the baseline of the entire regardless. Okay, now I see what's going to happen here. So each, yeah, let's get rid of this thing. Close this. Yeah. So I say, okay. So this is based on the UI display. First text. So then if I say and suppose this is hello. Oh, so then this is an H tag and that. So this is my first text I have. It kind of squeezes based on so whatever fits this way. So this is one H tag and then I have what are you called? And then now if I kind of draw the baseline, so this is, let's say, let's have something. So now this is not theme. Let's change it. This is on the first line, right? So yeah, this is and, so these blocks will move in such a way, and then you have then you have then you have let's take and then this is 75 and then so this kind of becomes the last. This is last baseline, as I see. You can the first and yeah, this is a customization. Okay, on layout when using a edge stack with text views, it is a chance that text might truncate if you're not allowing them to wrap. Instead, you can prioritize which one will truncate last with layout priority. The default value is 0. Okay, so he's saying this applies to both edge stack and base stack. This is a modifier, though, right? So it won't come. Let's have it somewhere here. Chaining modification, and then capacity. So then there is something called as layout. Oh, this comes in content. Let's you can prioritize which will truncate last. For example, I have there's a chance that text might truncate if you're not allowing them to wrap. So which one will truncate last? So let's like, and then there is a text 50. What is this? And then plot layout priority 1. When using a horizontal stack, the text might truncate if you're not showing them to wrap. You can prioritize which one will truncate last. What does it mean, truncate last? What does it say? Layout priority. For example, it is to determine how you compute for space within a layout. You influence how much space that will take when available space is limited. Oh. So whether that should truncate or let me see. So what will happen is okay. How uses in a layout compete for space within a layout. So I say degree. You influence how much space that will take when that space is limited. Yeah. So it will be truncated. So we can control this truncation, is it right? Brings so this was swing. Oh, so this is yeah. Each element should not be truncated in case of space crunch by using layout priority. Then we have lazy edge stack again. The advantage of using lazy edge stack versus is it will display in case if the stack size is more. I mean, if the element size is more than the stack, then a stack will still display it, although it might be truncated. But then here we can, but here it won't. It won't show that. Then since we studied about lazy as oh this is lazy weak grid. Is grid before? Actually, this should come afterwards, but then that's okay. Okay. And then alignment. Remember this will be vertical alignment, right? Vertical and bottom. Now it's scroll. Now what is a scroll? So now the next container element is a scroll. It provides like a scroll bar. Let's see. You haven't. The scroll will come before grids. I guess we have a stack, crazy, such. No, I guess introduce scroll view. It's a container though. You kind of have like a scrolling thing coming in, right? Since we haven't done with this, we haven't studied scroll, we will keep it that way. Then we'll see depth again. It's a 3D space stack, right? One top of each other. Okay. Note that the color is pushing out view, taking the entire. Now Z stack is the pull-in container view, the view that overlaps with the child on top. Z represents X. You learned about creating layers. Z stacks is another way to create layers. They use that control their own sizing space. It's a pull-in. You may think it's a push-out because of the first example, but that's actually the color that is pushing out. So you set the depth of the order of the views inside the Z stack. Safe area is the part where you import UI elements consistently go being covered up notch, and you have this dynamic island, right? Then ignore safe area. Okay, so there is a thing, right? This dynamic island is something that is new. No background. Okay, you can layer on top. So then Yosemite is something that is inbuilt, I mean, and then can do the alignment in the so Z stack. Now it's a 3D, right? So you can do in both X and Y direction. The Z is filled. Yeah, so go great. The grid creates invisible columns that we use. First, let's see. So we got lazy which stack, then see LazyGrid. We haven't come to scroll. Wait. So now let's do a grid. What's a grid? And then let's do grid. So in grid, it creates invisible columns that we use in other rows. So I have my grid row. A color is a pusher too, so it will make the column as hard as possible. Just that the view stays within. So whenever I do color dot blue, it kind of pushes the view on the column one. Overlay text. Column. Okay, so grid. Okay, so basically what grid view is having is basically grid view is having a grid with rows, and you're going to make a grid view. It's organized child views in a grid-like structure with defined rows and okay, so it will organize it. And rows and columns. So this is a grid. Then let's say this is rows. This is row 1, row 2. This is column 1, column 2, column 1. It's going in this direction. So now let's so we need to mention the rows when we declare a grid. So let's go to this. Let's have a grid. And then inside that we need, this is a grid row, and we have text. And this is a row, and then what if we have another, I say grid row, then say then I said text, then I said this is row 2, some parentheses, this, okay, and extra one, set this. So this is a row 2. Just remember, what if I have this text, and this is in the first row, so let's see, this is first row, second column. Now it makes sense. Let's get rid of this. This is my grid, right? First row, and then this is first row, second column. The comparison, if you create the same, You can do the same using baseline and you can better understand how grid creates invisible columns without a grid. Other view allows with their own layout. You can do this with H-tag and H-tag, but it's more efficient. You can have an H-tag and you can have so see the amount of code that you need to write here. Yeah, that is. And there is no column. For example, if there is one, although the shares, so even though like it's trying to replicate the same thing. Oh, so this is a yeah. Actually, it should be beneath this. Oh, this can't. We will have to move some spacing. Get that right. Column count. The grid row will the most used will establish how many columns there will be. So this is one. This is adding a number reasons. So he's saying how is the column, like how many columns will we have. We are mentioning the rows, right? He's saying how many columns will be. Then the number of columns is okay. No. This isn't the grid, but yeah, it should be the grid. This means it will follow its own layout. Yeah. So even so there is some important points he's saying. Suppose if I mentioned if it's okay, if I have a view. It's present. But not in the grid row. It will have its own layout. Own layout behavior and not grid layout behavior. Sizing. You can give a size. The width is okay. Oh, he's saying now there is some issue, right? A width is set to this column, but as you can see, it does not determine the width of whole column. How do we make it weaker? So the second row's column width also is same. No, why is that? By using there is some grid by using the unsize and you're telling that create cell not to size but to use the size of the other using the same row or column. You know, and this is sizing the entire column, so I can have two axes, right? Great. Okay. So now there is something called sizing entire column or row. So then um, uh, so let's say no, let's get rid of this box. Like in UI you won't have this box, right? So let's say if you want equal size boxes. Okay, let's this is this is this is we are making sure, but if you yes, no, this is of equal size. So this is let's go, let's change the color and say this is column. So we use this is grid cell and size axis, and then you do this is vertical, and then this is horizontal, right? And then this is grid cell and size axis. This is not horizontal. So then you might say, why not use frame, right? So I say, why not use frame for sizing? It won't size entire row or column. Then also you can have horizontal and vertical spacing. No, spacing between in the grid, right? Then you have something. So this is spacing in the grid. So then you can do two, right? That is horizontal spacing and there is vertical. Both of them are initializers. These two initializers to grid. You can have cell span multiple columns with them, like so spanning entire columns. It's not spamming, it's spanning. You can have cells. I say entire row. The first is you can have send, yeah, spanning, or basically I'm then so then you can add the modifier and I say so this is dot grid cell columns and then can we span them? So there is no something for, do we have grid cell? Oh, there is actually no, this is wrong. If not, it will be placed entire the, yeah, more than one column. Spacer. So this is good. This is basically going to add spaces. Now you may notice that when you add pull-in views, they appear on the center. You can use spacer to push this views apart away from the center of the screen. Remember, this is for pull-in views. Like it's used. There is and spacers. Where is spacers? I had written it. Just so the thing with pull-in is the pull inside, right? If it's a pushed view, yeah, let's remember. Push tool will occupy entire space size. Adding space in between pull-in views only. So then I say spacer will add spaces between pull-in views only. Pushed views, why don't you? How will you space it, right? Yeah, color, that thing kind of pushes it. This is good. Let's see something. Okay, there's no need for a restart though. But yeah, text. Just this. But this is only taking this much space. Now see what happens when I give it a background color or something. So let's do color. It is. Do we have something like? Let's color it. There was some example that was pushing it. Yeah, this color. Oh, it's so you. So this color dot green. So remember, it kind of took the entire thing. Oh no, we don't need any assistance. I am go to canvas. Yeah, you see what happened to this. Although it's this much, remember, not the entire thing. Kind of pulling. Yeah, this is not good. Spaces. Okay, so then evenly spaces uses so the location where you put the spacer is important, right? If you have suppose two stacks and you put the spacer in between, it does even spacing. So then this is text. Yeah, see, this is evenly spaced. If you see, the thing is, this elements are pushed up, and then once you get this arrow, you have this space. So it kind of does even pushing. And then when it's on an edge stack, so this is, yeah, see, so that it will push element so that this from the screen to how much ever space that element or you can occupy, only that. Yeah, evenly spaced. Now this is how to do an evenly spaced thing. Example, so you put it at a very like evenly spaced space before, space after, and then even after the last element you have some space. So this is the edge. Oh no, this is the edge tag. Space we have. Then inside this edge tag I have names and color, right? This is names. So okay, so this is the edge tag, so you have space here, and then you have some space in between, and then you have some space at the end. So there is a space. This edge tag, I'm talking about this thing. Edge tag alignment leading right. Yeah, this is the one. So here you have some space, and then it kind of pushes this as well. So now the only available spaces, the minimum length. Okay, now what does minimum length? Consider minimum length space. Like how much should be the space? Okay, so then yeah, you place it in proper behavior, and then I have minimum length. So then this minimum. What this does, you can set a minimum space to exist between views. So this should be the minimum. Using minimum using, no, this is done using a mini initialize. Now relative spacing, relative to something. How is this? Relative spaces are views and can be modified. Like notice the spacing is inside the text, and then our views and can be modified like views. So you can have a background color blue. So spacer. This is a V stack. With text spacer. Font size large. Relative spacing gray. You can add more spaces to create relative spacing in comparison. Then I have dot infinity dot padding background. Okay, this is the of color on you. Foreground is text content dot black. Okay, then I have this h tag. Then I have a v stack, right? In v stack, the first thing I have is a spacer. Oh, so see what is doing this color dot blue width. This is the v. This is h tag. So then inside that I have a v stack, and this width is 5, it's blue. Then I have this text 30% down. Then I have a little okay, this spacer is oh, so he's saying is this is actually what the spacer is. Ideally there shouldn't be anything, but you can remember spacers are view, right? It is a view. Spaces are views and can be modified like a view. That is what you mean. Okay, this is relating. You can also use spaces horizontally to place use geometry reader. Now geometry reader view is important. It kinds of gives this is Yeah, provides access to the size and the position of the views within their parent container. So you have the parent container properties. Yeah, you have access to size and position. Now remember, this is a relative thing. It is geometry reader is, it's difficult if not impossible to get the size of view. This is where geometry reader is push out container. You cannot get it. Child views. This is a view, right? It will allow you to inspect and use properties that can assign width, safe area, insects, which can help you dynamically set the size of the views within so that they look good on their size device. It's a view, remember. And what does this do? It cares. This is a geometry reader, I guess, is a relative view. So if you come this, and we had studied this geometry reader view. Geometry reader view is a powerful view. Dynamic. So it is, yeah, it's relative to the parent, right? So suppose this is, I say, goal is it. You just adjust views based on the size of the parent. So this is on child views, as I see. This is working on child views and adjusting the size. If I see, positioning. Now this is also going to, it will always position with respect to the parent. So we can cut the coordinates as well. So coordinate space dot local min max. Then you have LazyGrid. The grid item sounds with the size and you will know about this. Now what is this thing? So this is this creating no, how much is left in this? LGCH grid, LazyV grid. You scroll, I guess. Scroll views, control, and view that fits. Then you come to the next row. It's not that bad. Let's see how it is. Yeah, it is. Is based. It's just based on the parent view. Yes, with respect to the parent view. That's how it works. Okay. Yeah, that's all. with this lecture. See you guys in the next one with some code. This was mostly theoretical. In the next, I'll try to cover some code snippets. That's all from my end. See you guys. Take care. Bye.